Hi, this is topic 4.1, and we're talking about continental drifts, plate tectonics and continental drift. So, just as a very quick recap, continental drift is the theory that all the continents were once joined into a single landmass called Pangaea, surrounded by one vast ocean called the Panthalassa. The theory is that this supercontinent broke apart and the continents drifted apart. That's what Pangaea looked like 200 million years ago. And the evidence for this was that in the similarities in the shape of the coasts, and there was fossil remains found on both sides of the continents, and the plant and rock remains. So that's a quick overview of Pangaea. So continental drift. So we're going to be talking about crustal boundaries and how do these plates, the continental plates, interact at their boundaries. And I've got to just mention in 1977, World Ocean Floor Map was created by Bruce Heason and Marie Tharp. She was one of the most famous women scientists of the time. And so she was an oceanographer, and she helped to map the ocean floor. And this is the most comprehensive map to date of the ocean floor and what it looked like on a global scale. This is her then and now. I can't spend too long on that, but she was not allowed on the boat to go take the measurements. She stayed back in the lab and recorded everything and drew the map. So crustal boundaries. So for the AP exam, we're going to need to know the three types of crustal plate boundaries. And those are convergent, divergent, and transform plate boundaries. So tectonic plates are constantly moving. A long time ago, we thought that the Earth was just static and that nothing ever changed. But now, of course, we realize that everything's always in constant motion. And anyway, as they move across these hemisphere and form plate boundaries, they interact in these various ways. They interact in the convergent, divergent, and transform ways. So these are just very quick examples of it. And we're going to talk about each one of them. So convergent boundary, that's where two lithospheric plates are coming together. And an example is the India plate, which is pushing upward into the Eurasian plate and creating the Himalayan mountains. And here it is. So when two convergent plates, the word converge, it means to join together. So when they converge, continental plates, right? When they converge, they lift upward and they can form mountain ranges. Subduction is a process where one plate will be pushed under another. So, the continental plates and the oceanic plates have different densities, and so this causes subduction of the oceanic crust underneath the continental crust, because the oceanic crust is much more dense. So it pushes under, so they collide and one goes under, and that's what subduction is. And this is the example of it. And this is the Nazca plate being consumed under the South American plate, which is right here. And on the map, it's showing you this means subduction in there. So that's what that is. For convergent boundaries, there's three types. There's the ocean to ocean boundary, the ocean to continental boundary, and the continental to continental. So the ocean to ocean boundaries can create, deep valleys in the ocean or trenches. The ocean to continental boundary is actually going to create that subduction that I was talking about, where the oceanic plate will subduct underneath the continental plate. And so that'll create like these arcs, these volcanic arcs or island arcs. And the continental to continental boundary, that's when you have two equally dense plates hitting up against each other, and they will push together and can rise up into mountain ranges. Okay, so my recording time is up for this, and I will be back for part 2. Okay. So how do I stop this? I forgot to use this. Okay, I'm going to let the 8 seconds run out. Here is a beautiful example of the Andes Mountains, which was in continental